All right. Let's begin our session for this afternoon. And today we will be discussing data analysis. So before I jump into the nitty-gritty of data analysis and how to plan for your analysis, how to think about your analytical process, let me just quickly just review the research planning itself. So you have the planning phase where you plan for your research. You have your preparation when you are preparing to actually do your research and collecting data starts. And then you have your analytical phase and your reporting, your writing up of your dissertation. So naturally, we would think of data analysis as beginning in the analytical phase of your research, but if we look at the overall research process, you will realize that actually the analytical process starts at the planning phase. When you are planning your research, it is also the time or the place where you are planning how you will analyze your data, what kind of data types you will collect, and how the analytical process or analytical methods will answer your research question and research objectives. So actually, the analytical process or part of the research starts at the planning phase. Okay. And then come to the analytical process itself. It also follows your research. So you plan how you will do the analysis of your data, how you will prepare your data. For example, last week we covered how to clean your data. That may also require you to transfer data from paper to a software. It may also be the time where you are coding certain variables in your data. And then the actual analytical phase. So if you plan well your analysis or how you will analyze your data, then the analytical process itself is an execution of the plan that you had when you started your research. So I just wanted to just paint this picture, paint this process so that you can realize that when we talk about data analysis, the process itself actually starts at the very beginning of your research, not at the analytical phase, because that's actually the execution of what you've been planning when you planned out your research. There are two or three main points I want to highlight before we jump into how you can do the analysis. Firstly, because your research designs and your research objectives will vary, right? And the kind of analytical tools that you will use will vary from research project to research project. So in this session, I want to just cover some general principles and process or how to plan the analytical process or some strategies. And then maybe in the next coming weeks, we can jump into an actual or couple of actual analytical steps that you want to go through. The first thing that I want to highlight is, and it is also important for your data analysis, is you have to understand your study design. What is the study design that you used for your research? So the reason being, the study design can or will determine the kind of analysis that you will do, or you can do, or you cannot do. Was your study design a descriptive statistics or descriptive analysis of secondary data? For example, Molly's project where she's looking at all the cancer data. Or was it a primary research data where you want to understand a certain phenomena in the hospital? For example, Stephanie's project is looking at how a training program can impact or improve blood culture contamination rates. And for those two different research, the design is different. One would be a more descriptive, retrospective, or audit kind of study design, whereas for Stephanie would be like a cross-sectional study design with a intervention component being the training program itself. Others may think about, for example, Hans was considering at one point whether she wants to, or whether he wants to do a diagnostic accuracy assessment. It was also Dr. Herman's proposed idea to also look at how accurate gene expert is in picking up cancer in oral samples. So that would be a diagnostic accuracy assessment design. So depending on your study design, the kind of analysis that you will do will go in line with your study design. So the first point is make sure you understand your study design well, what study design you are using, why you are using it, and how you will tie your study design to your study objectives and your research question. Next key point is you should understand your data structure, meaning the types of data you have. For example, if you are collecting quantitative and qualitative data, then you will have a mixture of the types of analysis that you will do. Having said that, majority of you or all of you may end up getting quantitative kind of data. And the types of data that you may most likely collect would be like a numerical data, such as a ratio, or could be just a frequency data, or it could be a nominal kind of data where you could put in, say, yes, no responses, or you are categorizing into different categories, which will end up being a categorical kind of data. So those basic types of data structure that we learned in medical school, this will come into play. So when you are collecting your data, think about what is the kind of data that I am collecting. Is it a numerical data? Is it a nominal data? Is it a categorical data? And what kind of statistical tools that I can use in each of those different kinds of data? It will require you to do some bit of background reading and refreshing those foundational knowledge, but it will come into play, or it will influence how you do your analysis and the kind of statistical tools that you may apply. And because most of you will be doing epidemiological kind of research studies with quantitative data, I thought I should also highlight the two major types of quantitative analysis that you are most likely will do. One is descriptive statistics. For example, descriptive statistics come into play when you want to describe your data. For example, you want to describe how your data is spread. For example, you want to look at how skewed your data is. Is it normally distributed like the bell curve, or is it skewed to the right or skewed to the left? So you would use descriptive statistics there. If you are describing mean or mode or median, standard deviations, those are descriptive statistics that describe your data, how the data looks like. Some of you, and I think for Molly, descriptive statistics is all that you may need to do to describe your data and draw conclusions based on your research question or research objectives. Some of you may do a combination of both descriptive statistics and inferential statistics. Inferential statistics would be where you want to predict or you want to infer to a bigger population based on your sample, right? Remember, the kind of research that you'll be doing is you'll be drawing from a sample to do your analysis or to do your research projects. So if you're doing inferential statistics, then your research design would be done in a way and with your research objectives and research question that you are drawing a sample from a population that you have defined beforehand, and then your analytical process will help you do a certain statistical analysis that will predict certain variables towards the bigger population that you draw your sample from. Some examples of inferential statistics include things like doing t-test. T-test is so commonly done that sometimes, and many times actually, we don't use t-test the way it's supposed to be, or we misuse or sometimes misinterpret t-test. For example, if you randomly did your sampling, it's a random sample and you have a randomized method that you sample, and you did your descriptive statistics and wanted to see how your data was, and you saw that your data was normally distributed, then you would do those or statistical significant tests that are specific for data that is normally distributed, or are sometimes known as parametric tests. Whereas if your data is not normally distributed, then you would end up doing a non-parametric statistical test. So doing t-tests because you are comparing two means in itself may not mean anything much, but if it helps you to answer a research question, and if it is relevant to your study design, then it will make sense. So that's t-test. We can go on and talk about t-test, but let's leave it for a different time. The other kind of inferential statistics that you may be thinking about is doing ANOVA, or analysis of variance, where you are comparing multiple means. T-test, or chi-square test, you'll be comparing two means, or two proportions, or two rates for that matter, whereas analysis of variance, you are comparing multiple groups at the same time. The other types of inferential statistics that you might think about, again, based on your objectives and research design and research question, is correlation analysis. It could be a simple correlation analysis comparing two quantitative variables, or you could be doing regression analysis, looking at one quantitative and one, say, categorical variable, or you could be doing a multiple regression analysis, looking at different variables to predict another outcome, or the outcome of another variable. Again, this would depend on your original research question and your objectives and how you did your sampling. So these are inferential statistics. Many of you may end up doing a combination of both, but I think all of you will do descriptive statistics, but only some of you will be required to do inferential statistics based on your research design, research question, and research objectives. Let's talk about planning your data analysis before you collect your data. As I mentioned, be clear with your objectives. Formulate your research questions well. Remember, when you're formulating your research objectives and research question, recall that we discussed objectives being specific, measurable outcomes that are tied to your research question, which means those measurable outcomes should be linked to a type of or kind of data analysis. Secondly, study design. Again, tailor the analysis to your study design and to your research question. And then the specific outcome and exposure variables. By this, I mean decide beforehand when you're planning your research data, what kind of data that you will collect will become your independent variables and what data will be your dependent variables. So have that clear in your mind. Having done all of this, then it becomes so much easier to choose the statistical test or statistical method or statistical tool. Again, it will be dependent on your study design and data type. Excuse me. Sample size calculation. Again, we can have a separate session on this, but I just to say that if you want to do sample size calculation, do get in touch with me and we can discuss that separately one-on-one. If you are analyzing a registry, for example, how Molly did a research, then she doesn't need to do a sample size calculation because she's analyzing the entire registry. If you are thinking about doing inferential statistics because you want to predict or you want to see the association or you want to compare different means of certain variables, and you are sampling from a bigger population and you want to infer to a bigger population of which you have to define, then you may end up doing sample size calculation. And there's an entire process of going about how to do sample size calculation. Just basic thumb of rule, they say 5% of your target population could make up your sample. But again, that's not accurate. So do get in touch with me and we can discuss further on how to calculate your sample size. I've sent out those handouts, so do look through. There will be some complicated looking formulas there, but once you understand what the symbols mean, then we can get online and use online tools such as EpiInfo or some other online tools where you can punch in the numbers and it will automatically calculate the sample size for you. Finally, plan about how to manage your data. If you manage your data well, which means you will be able to clean your data well, then your data will be of good quality, at least of good quality, and be easier for you to handle and do various analysis. Next phase is where after collecting your data, you are preparing for analysis. When you're preparing for analysis, things like cleaning data, you'll have to deal with it, handling missing data, duplicates, outliers, all those things. If you are coding your data, meaning whether you want to code yes as yes as 1 and no as 0, or if you are getting different variables, 5, do you want to code them as 1, 2, 3, 4, or depending on the kind of tools you are using? Or you are not going to do any coding and start analyzing as they are. But if you're using some statistical software, they may require some form of coding, which meaning you're just changing a letter into a number so that it can be easier to do frequency count and do means and things like that. Descriptive statistics, of course, we mentioned, that's where you summarize your data, things like mean, mode, median, standard deviation, confidence intervals, all those things. And then coming to performing the analysis itself, if deciding on what appropriate analytical tools to use, as I mentioned earlier on, will depend on your study design, study objectives, and whether your sample was randomly collected or was it a non-random sampling, and the type of data you have. If you're using t-test, remember that t-test can be done for either a non-random sample or a random sample. There are different, slight variation in those two. So you should be aware of how your data was collected. You can also do things like ANOVA we mentioned, regression analysis, those are inferential statistics. If you're using categorical data, then statistical significant testing would be chi-square testing. And if you are comparing different variables and predicting certain outcomes or associations, then you would end up doing logistic regression and not linear regression. Other more complicated analysis or inferential analysis, such as time to event data, these are done, or this is usually done in the clinical setting where you have a specific time frame at which you want to measure an outcome, and then you want to see the time it takes for a certain outcome. For example, how long it takes for a cancer patients to die, like what's the survival rate, how long they survive before or after a treatment. It could be you want to monitor a certain complication and you want to see how long it takes for the complication to occur with or without treatment. It depends on your research question and research design. You can do other more complicated things, but I'm mentioning all of this here for the sake of completion, but I think most of you will not go into this more complex study design. Some of you may end up doing multivariable regression or logistic regression, depending on the kind of data you are collecting. Just by discussing with you and when you were telling me about your research question and what you were trying to do, I was already thinking the kind of data you would be required to do and the kind of data analysis. So as you are planning your research and when we go through your study design and data types that you want to collect, we'll be also discussing the kind of analysis that you may be required to do after you collect all your data. And of course, statistical software, AppInfo, very common. It's easy to use after you learn it. If you haven't learned it yet and you want to know more about the AppInfo, you can freely download and then start learning, watching tutorials. Hans is very familiar with it, I think, so Hans can run some extra tutorial for the group, teaching basics about AppInfo, how to do basic descriptive statistics and doing t-test. And then I sent a link for the free software JASP, which is an interface that's similar to SPSS. Do take time to go through and do some simple data analysis based on either some fake data that you may generate or based on some audit data that you have. And complex statistical tools such as the license fee paid SPSS and Stata and Python. I don't think you may be required to do that unless you have an interest in doing further analysis or going into biostatistics or data analysis later on. You can start learning about all of these things. But for now, AppInfo is fine, JASP is fine, and Excel can do most of the basic inferential statistics that we discussed. Key points, key take-home points. Number one, have an analytical plan before you collect your data. Number two, understand your study design, why you are doing, why you are using that study design and for what purpose. Understand well your study objectives, and this must be tied to a specific or kind of analytical method that you want to do. Could be several. Number four, the analysis that you do must meet or must answer your study objectives. Many times, I see some researchers, especially when we are just starting out, and I had the same problem too, where once we get all the data and we just focus so much on the data and we lose focus on why we are doing a certain analysis. Remember, your study objective should always guide your analysis or the kind of analysis that you do. And that means you have to understand your data structure, meaning the types of data you have. And number 6 is most important also, and you may be asked about this if you are presenting in conferences, or maybe after you write your dissertation, is the limitations of your study design and the limitations of the kind of data that you have, and whether that data can do certain things and what it cannot do, just being aware of those specific limitations. And finally, number 7, think about the best way to present your results, meaning it will require a combination of tables, charts, graphs, and have a plan or have a roadmap of how best to present a certain kind of data or certain kind of results. Presenting meaning how you will present it in your dissertation, or when you are presenting in an audience in a small group in a hospital or a bigger conference somewhere, how you are going to present those results. So just you can think about all those also as some of the parts of data planning process.